We're going to summarize the forms of linear equations that we discovered this week. Here's a linear equation that you should recognize. The equation y equals x is the parent function for linear relationships. It's also a specific type of linear relationship called direct variation because every point that is on this line is proportional to one another. This line has a slope of 1 because x is being multiplied by 1 even if we choose not to write it. All of the points on this graph are represented in the form x comma y, and we know that if we graphed it, it would be a straight line. We also know that we can modify parent functions by multiplying any number we would like to our x, change the coefficient of our x. Since we can make this coefficient any number that we want, we can represent it with the variable m. M will represent the slope of our equation. Remember that the slope is the constant rate of change in a linear relationship. It controls the steepness of the line, and we can represent that as the rise over the run, or the vertical change of our graph over the horizontal change of our graph. You can see that here, where 2 is the rise or the vertical change, and 1 is the run or the horizontal change. You will always find this relationship regardless of the 2 points that you choose on the line. And the slope of this line then is 2 over 1, or 2. We also know that we can change parent functions by adding or subtracting values from the end of the equation. This will represent the y-intercept, and we'll use the variable b, knowing that we can change this to any number that represents the current relationship we're dealing with. The y-intercept changes the position of the graph, and the line will always cross the y-axis at 0, b. This summarizes our first form of linear equation. It's slope-intercept form, y equals mx plus b. It's appropriately named because you can quickly identify the slope, m, and the y-intercept, b. For slope-intercept form, you should think about the uses that make the most sense for this form. It makes sense when you're given the slope, the y-intercept, or both. It also makes sense when you're writing an equation directly from a graph or a table. A graphing tip is that when you're given an equation in slope-intercept form, you can go ahead and plot the y-intercept right away. Then you can use the slope to find additional points on the graph. The example from this week that you should think of is the plant growth problem. In the plant growth problem, Beth was monitoring the growth of her plant. The information in the problem allowed you to make a table that looks something like this. Right away, I'm noticing that I can identify the y-intercept. This line will cross the y-intercept at 0, 4.5. I also notice that as x increases by 1, y is increasing by half, so the slope is 1/2. This allows me to write an equation in slope-intercept form by simply plugging in what we identified as the slope and the y-intercept. Again, the slope is 1/2, so I have y equals 1/2 x, and I'm adding 4.5 because that is where the line crosses the y-axis.